All right, welcome back to our last video on completing the square. We're going to tie everything together, look at some really hard problems, but before we do, a question for you: what's the difference between a piano and a fish? Okay, so I've got a bunch of quadratic expressions written down here. We've been completing the square, the series of videos leading up to this, on expressions like this. And I want you to think a little bit about what do these things have in common. Obviously, it's pretty obvious to tell some of the things that they have different. Obviously, their constant terms are all different. Some of them have pluses and minuses. The coefficients of the x terms are all different. But just have a think about what's similar, other than the fact that they're all quadratics. What are similar about these? First term is supposed to be an a. Now, if you remember back to sequences, when we did quadratic sequences, we said all quadratics can be written in this form: ax squared plus bx plus c. And if you look at all of my expressions on the left, they're all written in that form. They all have an x squared, an x, and a c. We also talked about, when we did this, that a couldn't be 0. Right? Back to our module 3 on sequences, we said a can't be 0. Why can't a be 0? Well, if a is 0, 0 times x squared is 0. So if a is 0, I would just have bx plus c, and that's not quadratic. Okay, so while there's nothing wrong with making a 0, if it is, then it's not a quadratic sequence, it's a linear sequence. And we're focusing on quadratics. We can only complete the square on quadratics, right? We need that x squared in order to make a square. So what do these things have in common? Well, hopefully you've noticed that the coefficient of x squared on all of these is 1. Another way of saying it is a is 1, right? That's 1x squared, 1x squared, 1x squared, 1x squared. A is 1 on all of these. That's what they all have in common. They have lots of other things in difference. They're all quadratics with a is 1. Now, as it turns out, in order to complete the square, a has to be 1. And that's what we've been doing. A has been 1 so far, and we've been completing the square. But what happens if a isn't 1? What can we do? Well, as it turns out, we can still complete the square, but there's some modifications we need to do. So we're going to look at how we complete the square for this expression. Now, sometimes you'll see the problem like this. It'll say express in the form a brackets x plus b squared plus c. Okay? So we're going to look at how to put it in that form. That's just another fancy way of saying complete the square. So how are we going to do it? Well, remember, in order to complete the square, we focus on this part here, don't we? The x squared plus x bit. We don't worry about the plus 7. We'll worry about that later. We focus on that 2x squared plus 8x. But a is not 1, a is 2. What do we need to do? We need to make a 1. So what can I do? A is 2. How can I make a 1? I can factor out a 2. That would give me x squared plus 4x. Okay, and then I still have my plus 7. Okay, again, that's just going to tag along. Plus 7 is just going to tag along for a while at the end. Okay, so hopefully you can see that 2 times brackets x squared plus 4x is the same thing as what's above it. Now, a is 1, right? If I'm just looking, again, I'm just looking at the bracket here, okay? I'm just looking at the bracket here, and I want to complete the square on that. So how can I go about doing this? Well, I still have my 2 out in front, okay? Now, how am I going to complete the square? Well, x squared plus 2x, so that's going to be, you're going to see here, I'm going to need another bracket. That's going to be x plus 2 squared, right? It's always half of 4. And then I'm always going to minus that 2 squared, which is 4. Okay, so in red there is exactly the same as that. I've completed the square on x squared plus 4x. Now, I still have my plus 7 still tagging along outside the brackets. This second bracket that I did here, very important, because the 2 out in front has to multiply everything in that bracket. The most common mistake students make is they do this. Okay, I'm going to write in the colors. They put the 2 and then they do this. They do x plus 2 squared minus 4. Well, now if you do it like I did in blue, the 2 is not going to multiply by the minus 4. If you look at what I've done up above in my Christmas colors or my Omani flag colors, red, green, and white, that 2 is going to multiply by the minus 4. Okay, so do not write it like that. We need that extra bracket. Okay, so we're almost there. We just need to tidy it up now. So let's multiply 2 times x plus 2 squared is 2 times x plus 2 squared. 2 times minus 4 is minus 8. And then I still have my plus 7 at the end. So I'm left with 2 times x minus 8 plus 7 is minus 1. That is my answer. Okay. If we look, compare it. So what up here? What do they just say? Sometimes the question says, what's A, what's B, what's C? So A is 2. All right. B is 2. And C is minus 1. All right. If I compare what's in red in that form, A times x plus B squared. This is how we complete the square when A is not 1. Okay, let's look at another example. I need to complete the square on this bit here. I need to make A 1. So how do I make A 1? Well, it's 2 times. Right now A is 2. I have to factor out a 2. So I'm going to have 2, okay, x squared plus 3x. Okay, and I still have my minus 3. Don't forget, it's coming along for the ride. Now I want to complete the square on this. So I have my 2 in front of my bracket. All right, x, that's going to be x plus 3 over 2 squared. All right, it's half of 3. Then it's always minus 3 over 2 squared is 9/4. All right, and I put that bracket there. This is the same, right? The bits underlined in green are equivalent. And then my minus 3 is still along for the ride. Okay, now I need to multiply out. I've got too many brackets there. I need to multiply out. So 2 times that is going to be 2 times x plus 3 over 2 squared. Then I have to do 2 times minus 9 over 4. All right, the 2 and the 4 cancel. That's going to give me minus 9 over 2. And then I still have my minus 3 out there. Okay, but I see what's coming. I've got my fraction. So 3 is, what, 6 over 2 is the same thing as 3, isn't it? Okay, 3 is the same thing as 6 over 2. So the last thing to do is tidy this up. It's going to be 2 minus 9 over 2 minus 6 over 2 is minus 15 over 2. Okay, so if they asked, A is 2, B is 3 over 2, and C is minus 15 over 2, if I want to know what A, B, and C are. Okay, what about now? Is A 1? No, A is not 1, A is minus 1. I need to make A 1. So how do I change the minus 1 into a 1? I factor out the minus 1. Okay? I have to factor out minus 1 from the 4x also, right? I complete the square on this. Okay, are those the same? Minus 1 times x squared is minus x squared. Minus 1 times minus 4x is positive 4x. And then I still have my minus 7 tagging along for the ride at the end. Now I'm ready. I can complete the square on x squared minus 4x. I got minus 1 in front. Okay, x squared minus 4x is x minus 2 squared. Then minus, it's always a minus. All right, minus 2 squared is 4. Okay, so again, be careful. I've completed the square. The 2 underlined bits in green are equivalent. And then I still have my minus 7 on the end. Now, let's get rid of that minus 1 in front. So I'm going to multiply through. Minus 1 times that is minus x minus 2 squared. Minus 1 times minus 4 is plus 4. And then I have my minus 7 tagging along at the back. So to finish this up, minus plus 4 minus 7 is 3. I'm done. That's my answer. Okay, so my equivalents, my A is minus 1. My B is minus 2. My C is minus 3. Right? That's what my A, my B, and my C are. Okay, another example. Is A 1? Remember, always ask yourself, if you need to complete the square, is A 1? No, I need to make it 1. I need to factor out a minus 1. Okay, now I'm ready to complete the square because a is 1. Again, right, we're only worried when we complete the square, we just look at the x squared in the x term. So, minus 1, if I complete the square, that's x plus 1 squared, always minus, 1 squared is 1, and then my minus 1 is tagging along. Now I need to multiply everything by minus 1. That's minus. Okay, and then minus 1 times minus 1 is plus 1. And then my tagging along is plus 1. I need to tidy this up. I get minus plus 1 is plus 2. And that's our answer. So what are my values? A is minus 1, B is 1, and C is 2, right? That's what my A, my B, and my C are. If I match them up here, that's my A, that's my B, and that's my C. Okay, another example. To complete the square, I focus on this. Is A 1? No, A is 3. So I need to make A 1. I can factor out a 3. That's going to be minus 2x, and then my tag along. What am I going to complete the square on? I'm going to complete the square on that. So let's go ahead and do that. X squared minus 2x is going to be x minus 1, right? It's always half of that 2 squared, always minus, right? Minus 1 times minus 1 is plus 1. And then my minus 10 at the end there is tagging along. Okay, expand my brackets. I'm going to do 3 times that, which is 3 times x minus 1 squared. I need to do 3 times minus 1 is minus 3, and then my minus 10 is tagging along. We're done. A is 3, B is minus 1, C is minus 13, right? That's A, that's B, and that's C. Okay, another example. Again, we're going to complete the square on this. A is not 1. Now, I factor out a 3. So 3 times what is 4x? It's plus 4/3 x. Okay, again, you can check it. 3 times x squared is 3x squared. 3 times 4/3 is 4. All right, these are going to get tricky, and usually these are non-calculator ones. It's just easier to work with fractions. So now I need to complete the square on that. It's always going to be x. What's half of 4/3? Well, 4/3 times a half is 4/6. Okay, which I'm going to change just to make life easier. Right now, 4/6, I'm going to change it to 2/3 squared. Then it's minus that number squared. 2/3 squared is 4/9. Okay, I need my other pair of brackets there because that's the equivalent bit to the green bit. Now, expand. Okay. That's going to be 3 times x plus 2/3 squared. Okay, 3 times 4/9 is 3 times minus 4/9 is going to be minus 4/3. All right, because the 3 and the 9 cancel. And then I have the plus 5. All right, but to make it working easy, notice I've got a fraction there that's over 3. So plus 5 is what? Plus 15 over 3, right? Plus 5 is the same thing as plus 15 over 3. It just saves me a step because I'm going to need to combine these fractions. So the last step, 3 minus 4/3 plus 15/3 is plus 11/3. So A is 3, B is 2/3, and C is 11/3. We've gone ahead, we've completed the square. This is about as tricky as it gets. Okay, we're going to leave it there, but before we do, I'm going to ask, I have a question for you to ponder. I'm not going to tell you the answer now. We're going to leave it and we'll discuss it when we see each other again. All right, this is a quadratic expression, okay? I can stick any number in I want for x. 1/2, 2/3, -1,000,000, 17/5, 3.29, and I can calculate what I get from that expression. My question is, what is the smallest value this expression could be? What is the smallest it could be? And I'll give you an example, maybe how you might think about it. What if x was 1? Okay, what would this be? Well, it would be 1 squared plus 2 times 1 plus 7. That's 1 plus 2 is 3. I get 10. Okay, what if x was 2? Well, I would have 2 squared plus 2 times 2 plus 7, 4. Plus 4 is 8, plus 7 is 15. Seems to be getting bigger, okay? Well, let's try something smaller. And again, remember, these can be fractions or decimals. Doesn't have to be whole numbers. What if x is 1/2? I would have 1/2 squared plus 2 times 1/2 plus 7, which is 1/2 squared is 1/4. 2 times 1/2 is 1 plus 7, so this is what, 8 1/4? Oh, well, that's getting smaller. What about if x was 0? Well, 0 squared is 0 plus 2 times 0 plus 7. Still getting smaller. Let's try some negatives. What if x was -2? I would have -2 squared plus 2 times -2 plus 7. -2 squared is 4 plus -4 is 0 plus 7 is 7. Oh, I get the same thing. So anyway, we could keep going, right? And we could keep putting other negatives and decimals in there. Right now, 7 is the smallest. We've got 2. Is there something that gives me something smaller than 7? I want you to ponder this and play around with this. What's the? Can we work it out? Would it take us forever? Do we have to try an infinite number of numbers? Remember, what about 0.12379? What about 0.39269? How are we going to know? How are we going to know? When we find one that's small, how do we know that there's not another number I can stick in there that's going to give me something smaller? This is what I want you to think about. And we will talk about this next time we see each other. So with that, that's sort of the end of completing the square. What's the difference between a piano and a fish? Well, you can tune a piano, but you can't tune a fish. Enjoy your day. We will see you later.